This we need to go through. So phenol is actually directly putting the OH group. Okay, but directly putting OH group is that can't come in, right? Directly, because the OH plus is not there, right? So first what you do is you put the Cl, and then you replace the Cl with the Dawes process, right? You replace the Cl with the OH group. I hope this is clear. And how you replace it with the OH group? By reacting it with NaOH at a very high temperature pressure. Why high temperature pressure are required? Why can't we do the reaction in under normal condition?
So because maybe it needs a high temperature and pressure to replace the to entirely remove the chlorine and add an O minus and A plus.
Yes, yeah, this is there in the previous chapter also, right? So the reason is basically the less reactivity of chlorobenzene as compared to the aliphatic alcohols. So why chlorobenzene is less reactive? What's the reason for it? Tell me.
So chlorobenzene is less reactive, maybe because it has more hindrance due to the chlorine. Yeah, so it will be more electronegative.
That is true. And one more thing we need to take care of is resonance. Just a second. There are lone pairs on the chlorine. Got it? And these lone pairs overlap with the pi electrons. Right? Is it clear?
Yes, sir.
So this carbon-chlorine bond has a double bond character. Normally, if you talk about the CH3Cl, okay, it is more polar, and positive and negative charges are in this direction. Got it? But once you have the benzene actually, the lone pair in the benzene, lone pair of the chlorine and the double bond of the benzene, they start overlapping, and you have resonance happening. So how much comfortable are you with the resonance structures, Ibrahim?
Yes, sir.
You're comfortable, right? Good, that's good. Actually, this so we have a double bond character, and it is difficult to break, right? And this lone pair will come at the ortho position, para position, right? So this explains all the things, okay, all the reactivities, all the reactions, okay, exhibited by the phenol. Got it?
Yes.
Is it clear? So the main thing is that it is very difficult for the animals to displace the OH Cl because it is it is bonded by a double bond, partial double bond character that you can see. Got it? So that's why to overcome that difficulty, you need to take high temperature and pressure. Right? I hope this is clear to you.
Yes.
Now, what is the mechanism? The mechanism is bimolecular NAS, and you take the NaOH, and the NaOH actually attacks on the position where the Cl is connected, right? And the minus charge actually circulates through the benzene ring. Got it? Is it clear?
Yes, it is.
So, but there is a point. It is not always so difficult. If you have a group, electron withdrawing group at the ortho and para position, it can make it easy. Is it clear or not?
Yes.
Because that minus charge is passing through ortho and para position, you can see. Right? And if there is a group which can take away the electron from ortho and para position, okay, so that will make the minus charge more stable. Is it clear or not? Got it?
Yes.
So if you have an NO2 group at the ortho and para position, it will make it more stable, right? And the temperature which you are going to take is going to come down. If you have 3 NO2 groups at on the ortho and para position, the reaction is going to become more and more easier, right? This is known as Dawes process, and this is from your NCERT itself. Can you see it? And can you compare the temperatures, Ibrahim?
So the higher the temperature, the lesser amount of NO2 groups will be attached.
Yes, without NO2, actually the reactivity is less. Okay. And with NO2, where the NO2, you need to be put. Where the NO2 need to be put? Tell me. Where the NO2 need to
So
be
the
put?
ortho and para. Oh,
Yeah, ortho and para position. Got it? And why ortho and para? Why not meta? Why ortho and para makes the rate more faster? You can see the temperature. Just if you have 3 NO2 group, you can just warm it, right? What's the reason? Tell me. Look at this. The minus charge is passing
because the
through
minus charge is on those positions. Yeah. So it will
ortho and para positions. Yeah, and if you have NO2 electron withdrawing group, that can stabilize the negative charge. Okay. It is going to make the rate faster and faster. I hope this is clear to you, right? Got it? So if it is asked to compare the reactivity, we have seen the sulfonation, okay, sulfonation of phenol and sulfonation of benzene, and then preparation of phenol by removal of SO3. That also we have seen, right? Is it clear or not? Got it? Any doubts on this? Okay. There's a sulfonation of phenol, right? Sulfonation you can do, you can take concentrated H2SO4, SO3, right? That you can take. And once you have the SO3H group, you can replace it by NaOH. Got it? So this I hope is clear to you. Right? Any doubts in this?
Yeah. No.
So from diazonium we have seen, we have applied in today's class also. Got it? So diazonium, how can you prepare? That is very important thing. So today we have discussed the preparation of diazonium by taking NaNO2. This is HONO, nitrous acid. Nitrous acid is actually NaNO2 and HCl. Is it clear or not? The temperature you should keep it low, 0 to 5 degree. Why low? Why low temperature you need?
What, sir?
Tell me why you need low temperature 0 to 5 degrees Celsius.
So maybe it's
Otherwise, this
because
diluted salt is there, no? This is going to not. This is going to break away very quickly, right? You need to convert it into phenol by adding water. Suppose while making, so in order to make it and keep it stable for some time, by the meantime you can put more water to it. You need to take lower temperature, 0 to 5 degrees. Okay. So this is prepared from aniline. Aniline you take NaNO2 and HCl, and that gives you benzene diazonium salt, and you react it with water, and when you react it with water, you get the phenol out of it. So this I hope is clear to you. Okay. This we already discussed, cumene hydroperoxide method, right? So this is all the methods we discussed. Acidic strength we need to discuss. Okay. Nitration and the reactions. Reactions, I hope this is clear. Remote even we did today. So let's do some PYQs. Got it? So you can tell me what will be the answer to this? So this is what is the name of this reaction? If you can recall.
but so is this that acetylation?
No, that was
Formation of salt.
COCH3.
This
That is
here we
not.
are making what? Salicylic acid here.
This is salicylic acid, not salicylic acid. This is salicylic. Got it?
Mm-hmm. Oh, okay.
Is it clear or not?
Yes, sir. Yes.
So this is salicylic, and so what was the name of this reaction? Very important reaction. We have seen it today. It starts from R.
Rhymotimin.
Rhymatim, right? Got it?
Yes.
So I hope this is clear to you. Okay, but the name is very. This is formulation of phenol. Okay. That attachment of CHO group on the benzene, phenols, right?
Mm.
And what is the what were the intermediates in today's class we discussed? So just try to recall the intermediates. Phenol we will convert to phenoxide ion because of the base, right?
Mm-hmm. So what is
What
going
happened to this
CHO?
chloroform? Chloroform, that you need to tell me. What intermediate you get from the chloroform? Bases can remove HCl. I can give you a hint. Okay.
So bases can remove HCl. So
From chloroform, remove the HCl.
I think it will be formal cation. No.
This is the chloroform. Got it? So remove HCl from it. And let's see what you get. That will be the intermediate. Because we need to think that how does phenol get attached to the CHO. Okay. So this chloroform got attached to phenol. Okay. That chloroform need to be converted to some intermediate, and that intermediate will get connected to the benzene. Is it clear or not?
Yes. So what? CHCl2, yeah.
Yes,
CHCl2.
HCl if you remove, so you are going to get CCl2, right? Carbene, dichlorocarbon. Is it clear or not? And
Yes,
how this
yes.
removal has taken place with the help of a base. Is it clear?
Ah, yes.
Right? So the electrophile involved which get connected to the phenoxidine, the minus charge of the phenol is dichlorocarbon. Do remember it and remit even react. Then once you have this dichlorocarbon connected to it, how it get converted to how the two Cl get converted to C double bond O. The two Cl get replaced by OH groups. You get two OH groups and water gets removed that and you get double bond. Got it? So that's how you get it. This is pole-based carboxylation reaction. And in this reaction, you take phenol and NaOH and CO. Is it clear or not? Any doubts on this?
No.
Pole-based carboxylation. This we have discussed today, right? So this I hope is clear. And let's do this PYQ. Very good question. This is phenol and zinc dust and heat, and today we have seen it.
So if we react phenol with Zn dust, so what will get?
Zinc dust is
We'll
here.
get benzene, yeah.
Yeah, we
We'll
have
get
seen today
benzene.
that is the benzene, exactly.
Yeah, and then if we react with what? CH3Cl and uh, aluminum chloride.
This is
So
important because this is from class 11.
yeah, so if we react it with those, so we'll get what? CH3Cl. Oh my God. So we'll get chlorobenzene. Yeah, chlorobenzene. Will it
No, no, not chlorobenzene. AlCl3 will remove the Cl. Got it?
Oh. So, so just a methyl group will be attached.
Hmm? Yeah, methylation. This is Friedel-Crafts alkylation. Cl will be
Yeah,
removed
so
by
methyl will be attached. Yeah.
yeah, CH3 plus. Okay. Yes. So this is what is the common name of this compound? Toluene. Got it?
Yes, sir.
Okay. And what happens with this KMnO4? This is a strong oxidizing agent.
So oxidizing, so it will remove the electrons. Yeah.
Yes,
So
the electron, but what should be the final product?
what benzoic? No, benzaldehyde. No,
The idea
benzaldehyde.
can be oxidized further that we have seen.
Uh-huh.
Okay. Because with this strong oxidizing agent, you are not going to stop at aldehyde. One step more, go towards aldehyde can further get further oxidized to carboxylic acid. Got it? Is it clear or not?
Yes.
So KMnO4 is carboxylic acid. So carboxylic acid on where? Where on the carboxylic acid? On the benzene ring, right? Is it clear or not? So benzene ring, carboxylic acid, this whole methyl group will first get converted to benzaldehyde, then benzaldehyde will get oxidized to benzoic acid. Is it clear, Ibrahim?
Yes.
This is the PYQ, okay, of NEET. Good question, basic question, but good question to recall all the reagents. This will discuss acetylation, okay. Aspirin preparation we have seen. Any of the reaction which is not clear in acetylation out of these four, they are same actually. What are the acetylating agents? Just quickly recall.
So pyridine H and H plus.
No, pyridine is used to remove the acid, okay, and because you will end up with a HCl, right? So where this HCl will be taken away, this will be removed by the pyridine. Clear? The main reagent which get connected to OH is it acid chloride or acetic anhydride. I hope this is clear to you. Okay.
Yes.
Acid chloride or acetic anhydride, right? Aspirin, acetylation, acetylating agents. Okay. This is the reaction with metals. How do you distinguish alphas and ethers? What is the basic preliminary test to distinguish between them? Can you just look at these reactions and tell me? As we have started ethers also. Yeah, Ibrahim. What is the difference? Just ether is also there in this slide and alcohol is also there. Many alcohols are there.
What? What's it? What?
How can you differentiate alcohol and ether? By using sodium.
Well, sir, if we used an alcohol, so no, if we used an ether, so the H will get replaced by Na.
No,
But
there
if
is
we used an
if you use ether, there is no H, right?
the H group, yeah, in the ether.
No,
No, in the
ether there
first
is
reaction.
no, this is alcohol.
Oh yeah, 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 sorry.
Got it? OH is
Yeah.
alcohol and ether doesn't have that H, right? So when you put
Uh-huh.
sodium, hydrogen will be liberated. Got it?
Yes,
Or any other active metal, sodium, potassium, aluminum, right? So you can see this hydrogen being liberated. I have written in the back as a byproduct. Got it? This one. Clear? Look here. But why no hydrogen is liberated here? What's the reason? Because there is, yeah, Ibrahim.
The most steric hindrance, yeah, so it
No,
can't.
there is no H at all. Okay, on the oxygen. Okay, you need OH, H plus. There is no H plus. Got it? In ether. Can you see this?
No, won't
There,
there be an H plus in the carbon group, the R?
but
That
that
is
is
also.
not, yeah, that is not acidic. Got it? That will not be substituted by sodium. Is it clear or not?
Yes.
Okay. Clear. So what is the test to distinguish preliminary test to distinguish alcohols and ethers? Just quickly tell it in 2 words. Just quickly what we have discussed. Yeah.
Sir, if we react in ether with Na, so hydrogen won't be liberated. But if we
Exactly.
react in alcohol with Na, hydrogen will be liberated.
H2 gas. Yes, exactly. So do remember it. Okay. Acid catalyzed hydration we have seen. Okay, we can use H2SO4 concentrated and H3PO4, right? So this let's do some more questions. Oxidation part. In oxidation part, we have seen oxidation, right? Dilute and the weak and strong oxidizing agent that we have seen. Okay, and today we have discussed all of that. Okay, copper is mild oxidizing agent. So primary alcohol you will end up with aldehyde. Secondary alcohol you will end up with a ketone, right? So this is all we have discussed. Okay, dehydration and all we have discussed. So let's do some more questions. Ethers and all this we will discuss after we cover it up in the next class. Okay, this you can tell me. Aspirin is an acetylation product of Ibrahim. Ibrahim, what is the answer to this?
So I think it's dihydroxybenzene.
Aspirin is an acetylation product of. What is aspirin? Just try to remember, recall that. So its molecule was a bit bulky molecule. So what was acetylene?
No, I think it will be that. Oh yeah, O hydroxybenzoic acid.
Yeah, orthohydroxybenzoic acid. This exactly. So when you do the acetylation, it is O-hydroxy, orthohydroxybenzoic acid, or 2-hydroxybenzoic acid. Is it clear?
Yes, sir.
Okay, good. Now the next question. This is similar to what we did, that CH3Cl and AlCl3. Okay. So what are P and Q, Ibrahim? And the remaining unknown molecules.
So if we get
First, what you can do is you can try to figure out this reaction. Right? First, try to figure out this. Then you can work on the PQR. This is a famous reaction. Got it?
if we have that benzene with the chlorine thing,
This is
so what will
preparation
get?
of what? Which reaction is this? Can you recall it? This is something related to preparation of phenol. That in the box. First, try to solve it out. Got it? Then try to move towards that outer part. Okay. Oxygen is being used, and P and Q, H2SO4, and this is isopropyl chloride. I hope you can see this first part. What happens with AlCl3?
So the AlCl3 will remove the chlorine, yeah.
Yeah, it will remove the chlorine and the group will get attached to the benzene. Yes, exactly. So what is A?
No, so what will get attached to benzene? CH3, yeah.
No, this whole alkyl group. If you take CH3, that will CH3 will attach. This what you have taken. You have taken isopropyl.
Oh, yeah.
This
So the whole
isopropyl group
thing
will
will
get
get.
attached, right?
Mm-hmm.
So this is isopropyl benzene, and there is a common name to it. Very famous common name. The Y on benzene, what it is.
Plus one,
Yeah.
I think.
What is the common name of this A?
It's just plus one.
No, this is not Cresson. Something which starts from C. Okay. It has a name starting from C. Got it? What is the name? Common name? Not cresol. Some later you are reacting with oxygen, you can see that. Some method for the preparation of phenol. This has a common isopropyl benzene.
Yeah, so A is isopropyl benzene. Oh, yeah, cumene.
This is cumene. Got it? And what is B now?
Oh yeah,
Got
yeah.
it? So remember it, because they can give it to you in another way, and but the whole process is exactly same that cumene hydroperoxide method. Got it?
Yeah.
But they
So
may
and then after
start with
that,
some different set of reactants to confuse you. Okay. Normally, you can also take some propene and H plus H3PO4. Okay. Or H plus heat. So that propene gets H plus, that forms a cation, and that cation get added to benzene. Similarly, in this case, we have taken Cl. Cl is removed, cation. Cation is added to the benzene. Got it? So you end up with a cumene, right? This is clear, right? And now B is what?
the B will be cumene hydroperoxide. Yeah.
Yes, cumene hydroperoxide. Yeah. So that is clear. I'm not writing it because you know. But P and Q, out of P and Q, one is phenol, because that was the method for the preparation of phenol.
Yeah.
And another one was acetone, which is a byproduct of hydroperoxide method, right? Because that isopropyl group, when it get connected to oxygen and you have the double bond of acetone. Got it? So this I hope is clear to you, right?
Yes.
Next is but which one is phenol and which one is this acetone? That you need to figure out.
So
Either the P is the phenol or the
P will
P.
be phenol and Q will be acetone. Yeah.
Yes, exactly. So how you identified it? Yeah, correct.
Because
Hmm.
in the reaction, always acetone comes, always phenol comes first. That's
No, sometimes they may confuse you. Actually, I have given you, so don't do that. Okay. They may write it acetone as first. There are two products. Okay. Normally, the acetone is the major product, so we write at acetone. Okay, with the phenol. Okay, it is the name reaction for the preparation of phenol, but don't always rely on that. Right. Try to figure out that which is going to come first. Got it? That I have given you another hint. Okay, another reaction. You can see, and that will help you to make out what is Q. That is a confirmation. Okay, so I have given you another reaction moving from this isopropyl chloride. So you can try this. So what is R? Ibrahim, can you see this one more reaction?
yes, sir.
So what is R?
So the aqueous coverage will remove
Cl.
the
Aqueous KOH and alcoholic where two reagents were there. Now tell me.
okay, okay. So Q is acetone. So if we react R with
Yes,
copper at
this is
300 degrees, so
exactly.
we'll get acetone.
Yes, so this is isopropyl alcohol, and that copper 300-degree copper red hot tube will oxidize it to acetone. Q is acetone, and this confirm that Q is acetone and P is the phenol. Got it? Right? Any doubts in this? Let's do one more question. This is related to benzene only. What is the structure of C? Also, you can tell me A, B, and C, all three of them.
So if we have the benzene with chlorine, if a
Yeah,
chlorobenzene,
this is chlorobenzene, exactly.
and then in the presence of Mg and an ether, uh, Mg and an ether. So the ether will come, yeah, I think.
No, ether is just the solvent to mix. The magnesium is a solid metal part, okay, small magnesium turning, small pieces of metal you take, you mix it with chlorobenzene, you end up with a famous reagent that is known as what it is known as.
Oh yeah, the Grignard reagent. So at MgCl.
Yeah, PHMgC, right?
Mm-hmm.
Right. So this Mg is positive and pH is minus because metals are positive, electropositive, that we know. Right? And you have aldehyde being taken, right? So what will happen now between this Grignard reagent and between the aldehyde which is taken?
The Grignard reagent is the PHMgCl, and the aldehyde is this
Yeah,
one, the other one,
yeah, this is
CH4COOH.
aldehyde. Yeah, so what will happen? Connect the charges, opposite charges. It will become very easy. So where are the charges in this? What is the charge on oxygen? How can you treat it? CH3, CH. How can you treat it? CO. O plus or C minus, C plus or O minus. How can you treat it?
C plus O minus.
C plus and O minus, exactly. And pH Mg bar, how can you treat it? MgCl. Mg plus and pH minus, right? Why? Because magnesium is positive, plus 2, right? Now tell me how to connect them. Yeah, right. Where to connect the phenyl group? On the oxygen or on the carbon of the this acetaldehyde?
Phenyl, so on the carbon.
On the carbon, yes. Then what will come on the oxygen? Mg, got it? And once you put water, what will happen? H plus H2. What will happen? This O minus will get converted to OH. Is it clear? Ibrahim, is it clear or not?
Yes, sir, yes, sir.
Okay, so just because just a second. Let's move on to the another question. What set of reagents are required to convert the phenol to chlorobenzene?
So it will be the fourth one because upon heating Zn dust, the OH will get removed, and then upon adding Cl to FeCl3, the chlorine.
Yeah, first you need to remove OH because OH is not there. So zinc dust, got it? And once you have the OH removed, you can connect the Cl anywhere, that is Cl2 FeCl3, right? Is it clear? But
Yes.
will this work? Suppose if I would have written SOCl2, or if I would have written PCl3, will that work or not?
Maybe it can.
SOCl to convert the OH to Cl. Is it correct or incorrect? What it is?
Yeah, correct, correct. It will form. It will form. It will form.
No, it is not correct because it is not an aliphatic alcohol. Remember, all the methods SOCl2, PCl3, HCl, okay, the one which we discussed in the previous chapter, they were applicable on CH3OH, ethanol, okay, they were not applicable on phenol. Why? Because there is a problem with the phenol, that phenol was having double bond character, so all these react. They will not be applicable in case of phenol. Do remember it. Okay. Got the point? What I'm trying to communicate to
Yes.
you. Very important point. Okay. So these methods, normal methods, will not work because they work with the aliphatic compounds. Got it? Aliphatic alcohol like ethanol. If you take ethanol, not with the phenol, but phenol is very difficult to replace that OH. So get it reduced first by zinc dust and heat. Then you can bring in whatever you want, right? If OH is there, if oxygen is there, let it be. Then it is not a problem. But if oxygen is being removed, then use zinc dust always. And then do the reaction again, whatever the group, as per the group which is required to be attached. Got it? Is it clear or not?
Yes, sir. Yes, sir.
Okay. This is a very famous question, and from all the examinations. Okay, everywhere it is being asked. So tell me. Yeah, Ibrahim. HCl, ZnCl. What should be the answer?
The first one.
First one. To just try to recap very important question. Okay. The above question and then retry this second one. There are two types of alcohol. Okay, one which is directly connected to benzene and another one connected to the normal carbon containing group. So that the benzene, the one which is connected to benzene is known as aliphatic alcohol, right? So aromatic alcohol, because benzene is an aromatic compound. And the one that is connected to normal carbon is known as aliphatic alcohol. Got it?
Yes.
So which is more reactive, which alcohol is it will not be replaced easily, and what is the reason why it will not be replaced easily? All the things need to be considered while answering this question. This question is very, very important, but very simple if you just try to recall, and once you do it very easily, you will be able to make out the final answer, right?
It can't be the third one. That's obvious. So is it the second
Can't
one?
be the third one. Yes. Yes, it can't be the third one. So which alcohol is more reactive? The one that is connected to benzene or the one that is connected to normal carbon?
The one that is connected to
The outside, that CH2 or the benzene, which is more reactive? This benzene one is very difficult to remove. Okay. Why? Why it is so difficult, Ibrahim? What is there?
the double bonds.
Partial double bond reacted due to resonance. Got it?
Yeah.
So it is very difficult to replace. Got it? So this is Lucas reagent, and that reacts with the normal alcohols. I hope you are getting my point. When this is Lucas, it is going to react with the normal OH group, but not with the phenol. That is very difficult to sort it. So this is OH is not replaced, only the normal aliphatic compound is replaced. The second one is the right answer. Is it clear or not?
Yes.
Yeah. Any doubts in this? So I hope this is clear to you. Two alcohols. Similarly, your aromatic halides, they are not easily replaceable. So that's why we use NaOH 350 degrees Celsius and 300 degrees temperature. Or 350 degrees Celsius and 300 atmosphere, right? A very high temperature and pressure. Wait. So that is very important. So let me in the class. In next class, we will be covering with the ethers and all reactions. So maybe in the next or just one more class, we may require to complete that. So which is in the next chapter, shall we start in the CBSE class? Shall we start with the coordination compound? Will that be okay? So maybe coordination or the I will be discussing it with all the classmates, all your classmates, and accordingly we will
Okay.
right? So okay, let me end the class. Bye bye. Take care. Good night.
Thank you.